So our learning target, if you look at it today in the agenda, will be to be able to come up with a geometric sequence to be able to figure out how much it's being multiplied by and then finding a number in the future. We talked about where this comes from. We had a long discussion actually about why we would learn something like this, and I said it's applied in programming, in how we would write computer code, and we all love those people because they keep the internet moving. They make the world go around. I hope we understand if you've never seen the movie. What's the movie with Justin Timberlake that's all about Facebook? Anybody seen? Yeah, The Social Network. So that is a great movie because it shows you. So we're just trying to figure out what number they're multiplying by each time. We call that the common ratio. So before we had the common difference, now it's the common ratio because we are multiplying instead of adding. Now remember, the common difference could be a positive or negative number. We could add, we could subtract. The common ratio could be a positive or negative number. We can multiply by a positive or we can multiply by a negative. A few things stay the same. We're still going to use this A1 to figure out some number in the future. The first term is still going to be considered, AN here for this, A1 for the first term, and the common ratio is going to be represented by R today instead of the letter D for difference. So that's how they're a little bit, you can tell them apart, that is. So here we go with 2, 4, 6, 8, 16. Who thinks they know the common ratio just by looking at it? Sabrina. Yes, that is multiplying by 2. Now, what you could do is you could always take a number and divide by the number before it. So you could do 4 divided by 2, 8 divided by 4, 16 divided by 8. It will give you the common ratio. So if you weren't able to come up with that on your own just by looking at it, take two numbers, divide them, and it will tell you the answer because division is the opposite of multiplying, right? Let's put some numbers underneath these to let us know that 2 is in the first spot, 4 is in the second spot, 8 is in the third, 16 is in the fourth. And again, I said this yesterday, that's what makes this confusing. It's numbers talking about numbers. It'd be much nicer if those were letters, right? A, B, C, D, but we would run out of letters. We wouldn't be able to find, the 200th number if we were using letters. And then again, if we're going to look for some number in the future, we call that the nth number. So some number way down the road. And in this case, let's talk about the 12th term. So let's use the explicit formula, the one that's on the top of your notes, to find the 12th term. Now before we do that, let's make a list of the things that we need to have in order to figure this out. So we need the first term, the R value, and the nth number. Who thinks they know all three? Who can rattle them all off? Krissa. Yep. Coincidence, not intentional. We're trying to find the 12th number. Very good. Okay, so I'm going to start this by writing down the generic formula. AN is equal to A1, okay, plus, ooh, that's what's different today, multiplying, losing my mind here, times, okay, and I want to be consistent for how they did this, the R value, and now we're going to use exponents today, n minus 1. Just like how multiplication is repeated addition, what does an exponent do? An exponent repeats multiplication, so it's a faster way to do multiplying. Let's substitute all these things in. We're going to try to find the 12th term. We are going to start at 2, the first number. We're going to multiply that by 2, the common ratio, and we're going to do that 12 minus 1. Same argument we had last class. Why minus 1? Why are we going to subtract 12 minus 1? Kylie. Of them, right? And that's why exponents are so much nicer because they show us repeated addition or repeated multiplication. So that's why we got the calculator, and we can type it in exactly as we see it. 2, parenthesis, another 2, parenthesis, and we're going to raise that up to the 11th power. So the calculator knows exponents before multiplying. So this part's going to happen first, then it's going to double it. Go ahead, press enter, and there you have it, 4,096. And with the help of a calculator, that wasn't all that bad, was it? Pretty good. 135. Who thinks they know it just by looking at it? Chrissa. Let's see, because all we need to do is take a number like 15, and choose the small ones, keep it easy, and divide it by the one before it. 15 divided by 5, you're right, it is in fact 3. We want to find the 15th term. Well, let's label these first. So we've got the first term, the second term, the third term, and the fourth term. So now we've got everything we need. Who thinks they can give us the 3 numbers we've got to have? Matt. First number is 5, multiplying by 3, and we're looking for the 15th number. Okay? So let's go ahead and use that formula. AN is equal to A1 times, or we can use parentheses, the R value, and we're going to do that one less than the number we're trying to find. So let's just take these values, because it was easy to come up with them, right? And just substitute them. So where you see the letter, replace it with the number. So we're looking for the 15th number, so N is 15. A1, we're starting at 5. We're multiplying by 3, and we're going to have to do that one less than 15. So 15 minus 1. Did I throw anybody off with the substitution? Please, if you have any questions, let me know in the chat. Let me know with your voice and your microphone. So we're going to have to subtract here and do 5 times 3 to the 14th power. Very, very important. I don't even want to say this to get this in your head, but very important that you don't multiply here, okay? Because what comes before multiplication? Exponents, parentheses, exponents, multiplying. And I know you see parentheses here, but that's really multiplying. So that is not parentheses. That's not something inside of those parentheses to do. So just go to the calculator. Type it in as you see it. 5, parenthesis, 3, parenthesis, raise it up. We had to do this 14 times. And again, nobody's going to know 3 to the 14th power. It's just not something you think to do, right? Whew! Look at that. Quite a large number, right? And we're going to see those quite frequently with these ones. So I got to write over here and get away from my little drinks. 23,914,845. There you have it. So in this one, instead of actually giving you a series of numbers, a set of numbers, they just tell you some things you got to know. So in a sequence, the first term is 4, the common ratio is 3, and we're finding the 18th term. So let's stay consistent. Consistency is the key to success. We need the first term, the ratio, and the nth term. Who thinks they can come up with all 3 of those just from the problem? Matt? First term is 4, multiplying by 3, and we're going to do this to find the 18th term. All right. I'm going to take a couple shortcuts here. I hope you're with me. So let's go ahead and write down A18. That's what I'm trying to find. We start with the first number, 4. We're going to multiply that by 3, and I'm going to save ourselves a step here. What's the exponent we're going to have to use if we're trying to find the 18th? I'm going to save ourselves a step, Andrew. What's the exponent I want to use? Kylie? Well, let's just put down 17, right? Let's just put it down. So instead of having to write the -1, we know it's going to be 17, 1 less than the one we're trying to find. And this actually might save you some confusion with how we do this. So after that, it's the calculator's turn, okay? So online calculator, cell phone calculator, they should all be able to handle this. So we're going to do 4, parenthesis, and then it's going to be 3, parenthesis, raise it on up to the 17th power. So there you have it. Whew, another Really, really big number. All right, this one is 516 million. 560,000 and 652. The 18th number, if we just started at 4 and kept multiplying by 3 over and over and over again. So, would you please change these notes by crossing off find the 20th term and write find the first 4 terms. That the first term in the sequence is 6, and then after that it gets tripled. So let's write down the fact that we want, or that we know, the first term A1 is 6 and the R value is in fact 3. After that, we want to try to find the first 4 terms, and we're going to use this formula. So AN is going to be equal to, well, I always have to go backwards 1, and then I'm going to multiply by R, and maybe sometimes parentheses around that to make sure that we do that first. Now, I'm going to explain this formula by coming up here and just writing the spot for the first 4 terms. 1, 2, 3, 4, ... Literally, what we're going to do up here is going to be what this is. It's just that we're writing it out. So if the first term is 6, who can tell me the second term? Kylie? Careful. Gonna multiply. 3 times 6? 18. How'd you do it? You multiplied the 6 by 3, which was in the first spot. Very good. Pause this for a second. Idea behind it. To find the second term, because we've got to go right in order. We can't just jump to the third term. We wouldn't know what the second term is. So 2 minus 1. So whatever this is, we just subtract 1. We'll go backwards 1, and we're multiplying by 3. So keep this going. It's going to be A1 times 3. What was the number in the first term? What was the number in the first spot? 6. So it's just 6 times 3, and we already know it's 18. So that's just the work for how you would figure that out. Sorry that it went on to that hard part that's difficult to read, but hopefully you followed along with me. Let's do it one more time. Third term. Maybe we can skip a step here. Third term. What are we going to use to find the third term? The second one. So let's maybe just start by writing A2. That's okay. We know we got to use the one before it. We're multiplying by 3. What was the number that we found in the second spot? 18. So let's replace that. We're just substituting. 18 times 3, we already know, is 54. Why not try to do the last one on your own? You know the answer. So we've got 2 rules. We've got Fahrenheit, we've got Celsius. We're obviously more used to Fahrenheit than Celsius. That's why we use that. But in this argument, we got to understand which one's better to use and when. This one is good to use when you're just trying to find a bunch of numbers in a row, right? Like really, really quick. But not so great if we're trying to find maybe like a number down the road, like the 14th term. So to find the 14th term of this sequence, would we use the recursive rule, the one that goes every single number, or would we use the explicit rule that allows us to jump to the future? Explicit or recursive? Recursive is what we just did, like one at a time. So the explicit one would be much better in this case. Okay, so we'll do that. So A1, R, N, we need them all. All right, who thinks they know them all? So we talked about the difference between the recursive and the explicit rule. For the recursive rule, we'd have to do this 13 times to get to the 14th term. Who wants that? Absolutely nobody, right? Who wants to do this just once and get right to the answer? All right, I thought so. So let's go with the formula that gets us right to the answer. Whoops, 1,500,000 94,326.